Hello, everybody. My name is Abdul, and I'm a cloud solution architect working at Microsoft in our data and AI practice. In today's video, I want to dive into how you can stream Cosmos DB's change feed to Databricks, and how you can leverage things like pipelines as well as Delta Live tables to do that, as well as give you a little bit more of an understanding of what change feed is. So just a quick roadmap of what we're going to be sharing today is I'm going to introduce you to some concepts on change feed, what it is, the different applications of when you should use change feed, and the different applications that might be well suited for you if you're a business and thinking about using Cosmos DB, and how this particular feature will help you immensely. Secondly, I'm going to give you an architectural view on a demonstration that I've created in my subscription, and I'm going to be showcasing that demonstration in this video. So let's explore a little bit more on the different applications of Cosmos DB's change feed. So let's say you have an application that's using Azure Cosmos DB data, let's say telemetry data, or you have a very busy e-commerce website. Obviously, the data ingestion is happening at a very, very fast rate, and there's a lot of changes that might be happening, inserts, updates, even deletes, and you might want to keep track of all these changes that are happening. And this is where the change feed comes in. So the change feed is a persistent record of the changes in the order to which they occur. And just a side note, the only API that doesn't support change feed right now for Cosmos DB is the table API. So back to change feed, any operation, so you'll be making on a container. So whether that is inserts or updates, those are all going to be available to you on the change feed itself. Specifically though, for deletes, those things are not actually logged. No delete operation is actually logged in the change feed. However, you can make a soft marker, and this is something that I'm going to get into later on. You can create a soft marker that will be able to tell you through the change feed if this is something, if this is a document that was deleted, for example. So with all this being said, why do you use this change feed? So there's like 3 different scenarios here. So let's break it down a little bit. So we can use the change feed to create, for example, a live migration where, for example, you want to test a new partition key because you realize that your current strategy or your current key right now isn't the most optimal. You're seeing throttling in your partitions, and it's simply not as easy as, hey, let's increase the request units, because you're not solving the underlying problem. You might increase the request units, and over time it'll be okay, but once that the same problem with the throttled partition is going to happen again. So you might want to move or create a live migration where you're going to be testing out a new partition key. So you can stream that change feed, all the changes that are happening, you can stream it, for example, into another container, in a new container, with that particular partition key that you want to test, and place it into Azure Cosmos DB. So that is something that you can do before making a full migration to another Azure Cosmos DB container, and which might cause a little bit of a headache. So that is a particularly very useful case scenario. Another way you can do is, let's say you have, you want to create like a materialized view of the data that's incoming in. So let's say you have an application and you want to keep track of the events of, for example, where your customers are viewing or adding or purchasing an item. So every time those changes occur, you'll want to send an event to that particular to the consumer. So for example, let's say the consumer has put all the items in their shopping cart, and now for whatever reason they left. The change feed reads it, and through the form of an Azure function, will basically send an email to that particular customer and tell them, hey, come back. Here's a promotional offer, and this might increase the likelihood of the customer purchasing that particular product. So that's something that you might use. Another scenario is, let's say you want to stream that particular data because you have real-time dashboards that you want to be able to use, or you have, for example, you want to do some machine learning on it, so it can feed your downstream applications through the use of, for example, Databricks. And this is something where the real-time processing of that data might be very, very useful. And you can use or leverage things like Apache Spark that found in Databricks or in Azure Synapse Analytics to accomplish this. So this is actually what we're going to be doing over here. We're going to be leveraging Apache Spark in Databricks to read that change feed, and we're going to be using pipelines and Delta Live tables that we're going to get into later on to make that happen. So this is just a few core concepts on change feed and the different applications of when it will be used. Now let's look at an architecture of what we're going to be demonstrating today. So I created a Python application that basically scrapes the Twitter for data. That data is going to be incoming into Cosmos DB. And through the change feed, it will be read into our Azure Databricks workspace through the help of Azure Key Vaults, and I'll show you how we can configure that using the Databricks CLI. And then we're going to be converting in real time through the use of pipelines that data that's coming from the change feed from bronze, silver to gold. And in that final gold layer, maybe this is where our business intelligence team or our machine learning team can leverage to extract or build real-time insights of the data that's incoming in and make your business as well as your application more effective. So as you can see, I created a Python application here that basically reads Twitter for any tweets that are related to FTX. And it extracts 5 main attributes, which is basically tweet ID, user, tweet, the created at, as well as a follower count. And this is all being ingested into Cosmos DB. So I've already created my Cosmos DB account. This is what the data is being fed into. If you aren't very familiar on how to create a Cosmos DB account, you should check out my previous video. It has all that data there. As well as if you don't have, for example, you just want to have a test environment of Cosmos DB, you can sign up for a free tier where we'll give you a particular amount of request units and storage that you can play around with. It's quite a significant amount, so it should be more than enough for you to be able to test and see the power of Cosmos DB. So as you see, more and more data is being ingested into our Cosmos DB account, and this might be a good segue into actually seeing or overseeing what is actually happening into our Cosmos DB account. So if we go into our Azure Portal and head on over to the Cosmos DB account that you created or have, you'll see that in mine, I've deployed it in Canada Central, as also I deployed it in a serverless way as well in its capacity mode. You could have chosen a provision throughput model where you could choose between a manual throughput as well as an auto scale method. But we chose serverless here. We're in basically a development environment. We are not going to obviously productionalize any of this. This is just for demonstration purposes. And the reason why I just want to highlight that we did launch this in Canada Central. The Databricks workspace that we're going to be heading over also is in Canada Central, and the Azure Key Vaults that we're going to be looking at is also launched within the same region. So just something to think about and something to note that you want to have that consistency across your resources. Then if you go on Data Explorer and let's just see the actual data. So we have the database Twitter feed, and in that we have a container called tweets data. And this is where all the items are actually being ingested in. And this is continuously getting larger and larger as more data is incoming in. You see here that the tweet ID is a partition key that we chose for our particular case. In this demonstration, it offers the highest cardinality, and it offered the best solution, or the best basically a partition key in this particular example. So now we saw our container, now we saw our Cosmos DB account. Let's head on over to our Azure Databricks account, and basically let's go on Cosmos DB connector that I have here. The notebooks, just note that the notebook is something that I will actually link in the description of this video, so you don't have to copy and paste. Just know that I will link it in the description of this video. So what we're doing here on a high level, and I'm not really getting into this just yet, but what we're doing on a high level is we're setting up some global parameters that indicate the endpoint, database name, the container name of where Databricks should go to read that data. Then we're creating a config JSON object where it's basically passing in a lot of the different parameters that is required for the connection. We're reading the OLTP, and you notice over here it says OLTP load, right? So basically you're actually reading the transactional database that you have in Cosmos DB. This might have an impact in your RU if you're seeing that this process is slow. It's Spark is reading Cosmos DB in a slow manner. You might want to adjust your request units by increasing it, because what might be happening is you might have a little not as much RUs as you need to really account for the writes that are happening from your application and the reads that are happening from the data from a Databricks perspective. So something to think about if you're having performance issues there. What we're doing as a one-time load is we're actually loading up the data, and as you see here, you have like a pretty close you have the data table here that's being read from Cosmos directly. You have a checkpoint where basically Databricks will or the Spark session or this particular streaming job will know when the last time it streamed was, so, and to continue from that point onwards. This is the whole point of that, creating that table timestamp. Is, let's say you're making some adjustments, you stop this particular session, you come back in the next day, you need the stream to read back from where it stopped the previous day. And this is the whole point of keeping track of this particular time by doing that. as well as Cosmos DB, the actual change feed itself, the way it's configured, will also recognize and know when the last pull, when the last stream job was. Then we're going to be streaming that data, and from there, we're going to be using that to basically read into our pipeline and then create our bronze, our silver, as well as our gold tables that can be ingested for our business intelligence team or machine learning team or for reports, etc. But before that, let's go on to some things that you will need for sure. So if you go on compute, you head on over to your cluster, you head on over to libraries, you go on install new, then you go on Maven, search packages, you go to Maven Central, and you just search Cosmos Azure. Or better yet, we can just write cosmos.com.azure.cosmos. Download any of these three. They seem, oh no, you should download the 33212. This is what you should be downloading. This is the latest stable version of the Azure Cosmos Spark connector. So select it, install it, wait for your cluster to reload, and then you're going to be set from that perspective. So now that we have the library installed, I do want to head over to our notebook and go to our Cosmos Connector notebook here. And I just want I want to highlight this particular line, which says basically to grab the secret from this thing called Cosmos Master Key. Where is this found? How can we get it? And this is what I want to explain a little bit more. So sometimes when you're creating a notebook like this, there are certain things that you don't want to share to any given user. And so you want the user to maybe reference what we call a secret scope that has a value that is encrypted, and it can be referenced directly from Databricks. So this actually is good because you won't have to explicitly mention maybe confidential data such as your primary keys and have it exposed for users to use. So this is a way that we can help the security of our notebooks. So how do we do something like that? So if we go back to our Azure portal and go on key vaults, go on and create a key vault. Just make sure that when you're creating this, select your resource group, give it a name. The region, just make sure the region is in the exact same region that you have all your other resources in. This might be a very important thing. Just leave everything as is and create. I already have one, so let's go to that. And if we head on over to secrets, you'll see that we have two, Cosmos Master Key. So if you create one, just make sure it's manual, give it a name, give it a secret value. So what's this secret value? What this is referencing is the master key, which is also the primary key of our Cosmos DB account. So if we go on our Cosmos DB account and we go to our keys, this is going to be your primary key. And one way we can validate that is if we get out of this, because I already created it, and go to your secrets, go to master key, click on this, and go show that secret value. Sorry. You'll see that this is the primary key of our account. So then how can we make Databricks basically, know how to access this Azure Key Vault and this secret scope value? So we have to explicitly create that connection between Databricks as well as Azure Key Vaults. So how can we do that? First, we need to grab our workspace name. So if you go onto your notebook, grab this workspace name right here. And if you don't have access to this, what you can also do is you can go on Databricks, your workspace, and your URL. This would be your URL here. What you'd want to do now is copy that URL, and maybe in the exact same tab, you just want to paste it. And the very end of this, you write secrets and then create scope, right? And then when you do that, it will redirect you to this page. So this is what this is going to be doing is this is going to be referencing our Azure Key Vault that we created earlier. And this is what's going to be allowing Databricks to read the secret scope that we created in our Azure Key Vault. So you can just assign it a scope name. For us, it was the the Cosmos Master Key, which is the exact same name. I told you this is not the best way to name them. It should probably be a little bit different. The DNS name, how do you get this, and the resource ID. So this is where I'm going to show you here. So if you go back to our Azure Key Vaults, go to keys. Oh, sorry, not keys, but secrets. Oh, sorry, not secrets, but if you go to overview, your vault URL, this is going to be your DNS. So if you copy that and paste it, this is going to be the first portion. And then the second portion is where it's going to be a little tricky, but you just have to follow the method that I will label here. So actually, let me just take it out and I'll just put it in a larger place like here. So this is what is going to have to follow. It's going to have to follow your subscription slash your subscription ID slash the resource groups slash your resource group's name slash providers, Microsoft Key vaults, and then your vault's name. This is what you have to follow in this particular order. Anything that has anything that's labeled like this is where you have to change it on your own. So this is something to really make sure you have this right, because if you don't, then the connection won't be valid. And yeah, so after this is done, you'll just create it. It'll just hit create, and it will be created. So how do you sort of validate if this is created or not? And this is where we would be able to use the Databricks CLI to ensure that we were able to see that. So where is this Databricks CLI? So if we go on here, if you go on your Azure portal, you click on Cloud Shell over here. Make sure this is selected as bash. And if you write just pip install Databricks CLI, let's see what comes up here. Okay, so you're saying it's already satisfied because I already have this installed. So after this is installed, what you would have to do is you have to get a token for you to be able to actually work with the Databricks CLI. So if you go on Databricks and you just go back to your workspace, for example, over here on the top right, if you click on it, click on user settings, generate a new token, you'll be given a time and expiration, and you're only going to get this token once. So make sure once you generate this token, it is saved. It is somewhere secure, because you will not be able to use it. You'll not be able to get it again or see it again. So just make sure it's stored in a safe way. After that is done, what you can do then is you can write Databricks configure token, and then the Databricks host will basically be your workspace ID, which we can find if we go on Azure. Oh, let's just do it here actually. Databricks, right? And the URL would be your workspace URL, which would be this. So we can just copy this, go back here, paste that here, and then the token. So the token would be exactly what you gathered or what you generated from here. And then once you do that, so let me see if I can do that real quick. And once you copy it and paste it, you'll see that nothing shows up. This is okay. This is okay. This is just a way for them to protect the token. So if you click enter after you've pasted it, then you can write Databricks secrets list scopes. So now you see that there's two vaults created. I have two created. One is called Cosmos Master Key, which is on the back end. It's referring to Azure Key Vault, and then it is referencing our Azure Key Vault, basically URL that we have. And this is how you know that this has worked. So basically what we have done and why all of this is happening is so when we go on our notebooks, right? When we go on our notebooks here, you'll see that when we run this command, it's fetching our Cosmos Master Key that is found in our secret scope that we created, the Databricks secret scope that we created. And then once that connection has been created from our Databricks to our Azure Key Vaults, it's referencing the secret scope in our Azure Key Vaults to retrieve the primary key value of our Cosmos DB account that we put there. So I know this was very high level, and this was sort of a little bit complicated, but I just showed you how we can do and work and see if we created the scopes properly or not. And this is going to be mainly, like I said, for for privacy reasons. You don't want to expose things like your primary key, because that will inevitably put you in a vulnerability state when you're in a production environment or even in a development environment. So that is just something to think about. And I just wanted to introduce this part here because you might want to use it for other areas. You might want to use it for your database name and your container name, and these are all things that you can do by following the process that we just laid out here. So now that we have this connection, and now we begin running these particular commands, and you'll see that here it says read format. You're reading the OLTP, which is the transactional load of Cosmos, and you're loading that directly into our Databricks environment here, which is in Spark. And then what's going to happen here is we have a checkpoint of the last time we actually streamed. So Cosmos or Databricks remembers, or your Spark session remembers when you read last. to make sure it continues from that point on and not from, it doesn't overwrite anything that it has already written. And you pass it all the configuration items here, you read it. And like I said, this notebook will be provided to you in the link to the description below. So once it's streaming, you're seeing that right now it is streaming. So how can we work with this Delta table here? And the way we can do that is through pipelines, as well as we can do that through Databricks live tables. So if we go to our workflows, we click on Delta live tables, you'll see that we have a testing pipeline here. So you can create a pipeline, and if you do that, then you'll just end up getting what I have here. And you'll see that we have a tweet data bronze table and a tweet silver table, and we can start them. But before we do that, let's just look at their settings. And these are things that you're going to have to create when you're doing it. So if you go, when you're creating your actual pipeline, you're going to be getting these things. So you're going to have a testing pipeline. Do you want it to be run in a trigger state or just continuously running? Just leave everything as is. The source code. This is the notebook that is going to be referenced in this pipeline to be executed. I'm gonna head there shortly. Just bear with me here. And the destination is going to be a database that's created in your Hive metastore. So more on that also in a second. So with all this being said, if we save it, right, and it's already manually starting right now. So if we go back to our workflows or our notebooks, so we go and compute our workflows, Delta live tables, testing pipeline, and we already have this here. So what we would need to do is we just need to go to our workspace and head on over to our testing pipeline. So you can just create a new notebook, and I just named it testing pipeline. And this is where we're going to be referencing and creating these bronze, silver, and gold tables. So what this is doing is creating or refreshing the live table that we have, and we're going to call it tweet data bronze. And the comment is this is a Delta live table, and we're selecting everything from the tweets in Delta. So what does that particularly mean? So if we go on our data here, and you see that in the Hive metastore on the default table, we have the data called tweets in Delta. So if we go over here, tweets in Delta, we select that, and you'll see that this table is constantly being refreshed. It has almost 1,500 files. And this is what's being used to stream, and this is what's being used to stream our Cosmos DB tables. And how do we know that? So if we go on compute, I'll select that, notebooks, Cosmos DB connector over here. You'll see that in the table here, you're merging it into tweets in Delta, and this is continuously running. And after this is run, we do some manipulations. We convert the date time to an actual date time we can use. And now this is going to be a tweet silver table. And all this is running in real time, and this is being pulled in real time. So if we go down here, for example, and then just cancel this out for 1 second, and we can just select everything from tweet silver. This will be the exact table that is reading from our Delta live table that we created over here. This is because the pipeline is running behind the scenes, as you see here. You see how it's all cleaned? Because the Delta live tables are running behind the scenes to refresh and update this in real time. So it's very interesting to see, and one thing that you should think about is, okay, how does the change feed work here? So in the sense that, for example, let's say we have this particular tweet ID in our Cosmos DB account. So we go back to our Cosmos DB, and this is just for demonstration purposes. So we go back to our Cosmos DB, and we head on over to our Data Explorer, and this is still data, it's still incoming, but let's just go to our items, pick any item, and let's just write great time. But before we do that, let's just take this tweet ID, right? Copy it, and we go back to our query, and just query this particular this tweet ID, and let's see what happens. So you see that we have two observations here. One of the observations is the reason why we have two is because we already loaded the full table before we started streaming. That's why we have this here. And the other one is what was just, this is the timestamp of the tweet that just happened as well. So even though there's two items here, the reason why there's two items again is because we loaded it twice, because we already did an initial load and then we have a streaming load that's loading in. But let's say we make a change in this particular tweet. Again, this won't change because this is what we already loaded from the initial OLTP pull. And the other one, what we have here, is the one that is being streamed. So what we should be seeing is when we when we update this item for whatever reason, right? when we update this item, we're not going to get another row, but this should also, in a live fashion, also be updated. So let's go and see what would happen in this case. So let's just change the great time to that, right? And then let's just add, oh, we're actually not going to do that, but let's just add the time. Let's change the time to 3, or not 3, but like, let's just add it to 12, right? And then let's just write update, click update over here. And now if we wait 10 seconds or so for this to actually take place, you'll see that what's happening is it's streaming that job. So it's obviously just recalling any of the live events that are happening. In our testing pipeline that we can find over here, or if we want to see a real life version, we can go to workflows, Delta Live Tables, go over here, and then you'll see that this is being run, and this is happening in real time. So if we go back to our table here, and if we run this, again, you'll see that the changes that we've made, and I just ran it a little bit before, but you'll see that now there is an update, and this update happened here. So if we go back to again, like what we changed this particular time to 12, and now this is also being reflected through this pipeline that we're not running at all. It's just automatically running because we already configured everything into basically our Delta Live table, our silver Delta Live table. And now you can make also a gold table, and the gold table maybe has even further cleaning that you do, or maybe you need to add attributes to this table. And in the very end, you can distribute this to your business intelligence, as well as your your business intelligence teams, your machine learning team, your data science team. All these things can happen now because you have this clean table. It's also being managed by Delta, and this is basically a process of which you can do that through this way. And another way we can actually do all of this is through Azure Synapse Analytics, through the use of Synapse Link, which automatically integrates through an analytical storage layer, which doesn't impact your transactional performance from Cosmos DB directly into Synapse Link. But this is something that if you just want to have a little bit more flexibility with it as it relates to the Spark setup, as well as the integration that happens from with the bronze to the middle to the silver to the gold tables, and using Delta Live tables in a Databricks environment, this is something that can also be done. So we just saw how the change feed is streamed into Databricks Delta tables through the use of pipelines and Delta Live tables, and we convert them from bronze to silver, and you can inevitably do it to gold, and then expose those views to maybe your business intelligence team or your data science team. But one thing that we saw is that only the last modification of the document will appear, and that's updates or inserts. You'll not see deletes, and I'll show you in a second why that's the case. And so the problem is we won't be able to see all the intermediate changes. So let's say that's something that you want to be able to do, and this is what Delta would be able to offer you, because when you're streaming the change feed, you're getting all the benefits of the Delta tables. It being asset compliant. You get the scalable storage. You get time travel based commands and like automatic versioning and timestamps. And these are all things that are would be afforded to you, or you'd be capable of doing if you were to stream the change feed into something like Delta, a Delta table. So one thing that you would want to do if this is something that you're interested in, and that is basically just seeing all the different changes that are happening in the change feed itself and seeing the logs of those things, then it's probably prudent for you to set the table properties from the beginning on that particular Delta table that's being streamed into. Let's say the original table that we streamed into is called tweets in Delta, and this is what's being what Cosmos is ingesting into. So what we can do is we can actually just we can just change the language to SQL. We can write alter table tweets in Delta, set table properties, and this will be Delta enable change data feed, and this will be true. And if we do that, and then we can write SQL again, and you'll see that if we describe the history of the tweets in Delta table, now you'll see the last change should be a change of changing the table properties, and that's what we see here. Done it just a few times before, but I just wanted to show it in this demonstration of how you can do that now. And so why is it important to do it even before the loading of the data into this Delta table? Is because no intermediate change will be logged or captured in this change feed if it wasn't set prior. So only the changes that happen in the change feed after this table properties method has been set on this particular Delta table then you'll be able to see all these intermediate changes. So with that being said, let's go on our Cosmos DB and then just go to any document. Let's go all the way down and just pick this, for example. And let's say we want to change something. So let's just change this to a 20, for example, and just click update. And because this is running already, the streaming job is running. Now, if we do another, if we write this again, there should be another version of this table that accounts for the ingestion or the update that just happened. So let's just do that again. And you're seeing now there's a new row and a new version, and this is what's accounting for that change. So if we want to see what actually happened, what changed, and that's something you can do here. So you can just write SQL select from table changes, and this will be default, and this will be tweets in Delta. And now you write the version that you want to be able to see what changes have been, what happened to it, basically. You know, 1501. And if you run this command, you'll see that this is exactly what we changed. The pre-image before anything that was updated, it was 1119, and now you're seeing that it's 1120, and all this is being captured, and all of this is what you can see. So now I just wanted to wrap up and just go through again what we did. So we had a Python application that reads tweets from Twitter that is being ingested in Cosmos DB. Now the change feed was read to a Delta Lake that we had in Databricks, and we converted that table from bronze to silver. We could have very well converted it to gold, and then those tables could have been exposed, and those views could be exposed with all the benefits that you would have from a Delta table perspective in terms of, you know, dynamic masking or row level security, and those are all things that could be exposed to different users or different groups within your organization to do different tasks. We also showcased how Azure Key Vaults and how creating Databricks backed scopes through Key Vaults, and how we used the Databricks CLI, how we generated tokens, how we accessed the Databricks CLI through the Azure CLI. And we showcased that entire process and why we would want to do something like that. And finally, I also showed you how we can look at intermediate changes in this particular architecture, because we get all the benefits of Delta when we are streaming that change feed into Databricks. So this is just the video. I hope you enjoyed and learned something new. If you did, please hit that subscribe button and the like button as well. It helps me out a lot. And if you have any other suggestions of any other topics that you might want to be covered in Azure, anything that relates to machine learning or data engineering or anything relating to Databricks, please do let me know, and I'll be more than happy to cover this topic. Thank you for your time, and I'll see you in the next one.